let's take a look at number 20. This is an example of a binomial distribution. Okay, and the instructions are find the indicated probabilities. Okay, so we'll take a look at parts A, B, and C. Okay, so here's the situation. 68% of adults would still consider a car brand despite product/safety recalls. You randomly select 20 adults. Find the probability that the number of adults who would still consider a brand despite the recalls is A, exactly 1, B, more than 1, and C, at most 1. Okay, so let's go ahead and write down what's given in this problem. Okay, we're told that 68% would consider a car brand despite the safety recalls. Okay, so P in this problem is going to be 0.68. That's the probability of success in a single trial. N is equal to 20 because you're randomly selecting 20 adults. And X is going to take on the value 0, 1, 2, and so on up through 20. Okay, in other words, X can take on no adults considering a car brand despite safety recalls, exactly 1 out of the 20 considering a car brand, and so on. Okay, up through 20, which would be all of them. Okay, so to get the corresponding probabilities, you can use the binomial formula by hand. Okay, recall that, let's see, for part A, we want to find the probability X is exactly 1. Okay, so using the formula, it's going to be N choose X times the probability of success to the X power times the probability of failure raised to the N minus X power. Okay, so by hand, we would be inputting 20 choose 1 times 0.68 to the first power times 0.32 to the 20 minus 1 power, which is 19. Okay, and it's not too bad of a calculation, but it is several keystrokes on your calculator. So instead, let's go ahead and take a look at how to get this in the calculator. So the probability X is equal to 1 using the TI-84. Okay, so what I'm going to do is I'm going to go to my distribution menu, which is a second key. So I'm going to press second, vars, and I want to scroll down till I find binomial PDF. Because we want to find the probability of exactly 1, we want the probability density function. Okay, so you use that one for exactly X taking on an exact value. The CDF is the cumulative density function. Okay, so that's the running total, and it has a lot of usefulness in a lot of these problems. Okay, but for part A, finding the probability of X taking on exactly 1, we would want to use the PDF. Okay, so the number of trials is 20. The probability the probability of success in a single trial is 0.68, and the X value in question is 1. Okay, so see how that copies it over to your home screen. If you have the older TI, when you select binomial PDF, you'll get to your home screen and it'll open up parentheses like that. So on the older TI, it will open up to be something like binom PDF, and then you'll have to enter in this order N, P, X, all separated by commas, then close the parentheses. Okay, so if you're using an older calculator for this problem, it would be 20.68 and then 1, all separated by commas, and then in that exact order. Okay, so on the newer TI, it's a little bit more obvious. Okay, so after you get the information put in, press enter, and notice that it's in scientific notation. Again, you guys all need to know how to reinterpret this in proper scientific notation. So this is about probability x is equal to exactly 1 is approximately 5.39 times 10 to the negative 9 power. Okay, so this e is 10 raised to the negative 9 power. I don't want to see the e in your labs. Okay, so you need to include all of this right here. 5.39 by itself is not a valid probability. Okay, so you do need to include the times 10 to the negative 9. Okay, so part B asks for the probability x is more than 1. Now, because more than 1 does not include the 1, we can go from 2 on. Okay, so this is really saying for a discrete probability situation, this is the probability x is greater than or equal to 2. Okay, so one way to do this would be to use the binomial PDF and find the probability x is equal to 0. Oops, sorry. Probability x is equal to 2 plus the probability x is equal to 3 plus the probability x is equal to 4, and so on, up to the probability x is equal to 20. Okay, you could theoretically do that, okay, but that would be very cumbersome. So what we're going to do is we're going to use the complement. Okay, so the probability x is less than or equal to 2 is going to be, greater than, not doing too well today, that's 1 minus the probability x is less than or equal to 1. Okay? Using the rule of complements here. So in other words, let's talk about this conceptually. The probability x is greater than 1 does not include the 1. And remember, this is a discrete probability situation where x takes on 0, 1, 2, 3, and so on with the corresponding probabilities. Okay, so probability x is greater than 1 does not include the 1. So the probability actually refers to this sum here from 2 on. Okay? But what we have in our calculator is the cumulative function. Okay, so the cumulative reads from x is 0 up to any other x value of interest. Okay, so what I'm doing is I'm taking the whole thing, okay, the sum of all the probabilities is 1, and I'm subtracting out the part I don't want. So I want to subtract this out. Okay? I want to subtract that out. So it's the whole thing minus the sum of the probabilities we don't want. Okay, so this is the workaround we have to do to use our calculator. So here I can use the binomial CDF here. Okay, so this is going to be the CDF, cumulative, because it's really the probability x is equal to 0 plus the probability x is equal to 1. Okay, now you could do those two separately. That wouldn't be too hard, but it would definitely be extra keystrokes. So to do this in the calculator, I'm going to put this in one step. I'm going to go 1 minus. Now again, I want to go to my distribution, scroll down to binomial CDF, because I'm summing those two probabilities, x is equal to 0 plus the probability x is equal to 1. Okay. Number of trials is 20. The probability of success in a single trial is 0.68. Now, what I'm summing up to is x is less than or equal to 1. Now, make sure you're in the right place. Okay, so I'm in binomial CDF, and my x value that I'm summing to is 1. Okay? Okay, so it's going to give me everything. It's going to give this entire calculation. Okay, so it's very close to 1. Okay, so the probability that you get more than one person who would consider buying a car brand despite the safety recalls is extremely high. Okay, now it's not exactly equal to 1, because that would be an event that occurs with absolute certainty, but it's extremely close. Okay. Okay, so now let's take a look at part C. Okay, part C is at most 1. Okay, so the probability of at most 1 most 1 includes the 1. Okay, whether or not the case of equality is implied in the discrete probability case matters. Okay, so you pay attention to the wording of the problem. So at most 1 includes the 1. So this is the probability x is less than or equal to 1. Okay, now we can use the binomial CDF directly here, because this is the same thing as saying probability x is equal to 0 plus, I'm tired, plus the probability x is equal to 1. Okay, I again can find those two separately using the binomial PDF, but it would just be a little bit quicker to use the binomial CDF. Okay, so binomial CDF here. And again, if you have an older TI, it will carry you back to the home screen, and in order you put in N, P, and X. Okay? Now I have the newer calculator, so when I go to distribution first, scroll down to binomial CDF, I get the screen. Okay, now this is the same information that we had from part B, except this time I am not subtracting it from 1. Okay, so in other words, part C is asking for this part here, at most 1. Okay, so that's the probability x is equal to 0 plus the probability x is equal to 1. And the at most 1 means we can include the 1. Okay, so now I want to go ahead and press enter. That's going to be a really small value. It's going to be the complement to this thing up here. Okay, so I expect it to be really, really small. Okay, and in fact it's about 5.51 times 10 to the negative 9. Okay, so it's about 5.51 times 10 to the negative 9. Okay, I hope that helps you find the pieces you need for the binomial distribution using your calculator.